So you want to build a turbo car or want to convert a stock turbo car maybe to a bigger turbo or change it or whatever. This is going to be a video on how not to blow up your stock engine, because it's a small public service announcement, I'd say, as I have experienced that some turbos, especially from Garrett, the GBC line, so the newer, smaller series of Garrett turbos, have had some issues in my experience with the wastegate actuators, which led me to doing this video and doing a small, well, basically video on how wastegate actuators work, and also a little bit on boost creep. First of all, what was the issue I was experiencing? Well, buying a new GBC 17250 or 22350 turbo that has a, in theory, 0.5 bar wastegate actuator. So that should lead you to believe that it is a turbo that in standard trim, if you don't change anything about it, should deliver 0.5 bar of boost, which is about 7 to 8 psi. While there are turbos where this is true and the wastegate actuators are actually delivering the set boost amount, on this one I experienced something else, which I'm going to show you later in the video. But the issue there was that the wastegate only opened at like 0.8 to 0.9 bar, which can be quite dangerous for stock engines. In my case, it was a 1.6 MX5 and running at 1 bar of boost almost, or even a bit more than that, with a stock engine and that size of a turbo can lead to bent rods. And yeah, that's where this video comes in, because I want to show you how to basically protect your rods from getting bent, or rather from how to check first if your wastegate pressure, or if your desired wastegate pressure is actually matching that what you actually want. This is why I have a few actuators here and a few types of wastegates in general. We have some internal wastegate actuators, which are actually from different cars. So for example, this is from a KO4 unit. So this should make about 0.4 bar. This should make 0.5 bar if I'm correct. And this, for example, should make 0.8 bar. And this external wastegate, so just to show you what this looks like too, should open at about 1 bar. So I can show you a few different scenarios of what they look like and how they work. And the other thing is, while these actuators say 0.5 bar, 0.8 bar or whatever, this is just the pressure where they start to crack open. So where the rod that is here starts to move. And because there is a spring inside that gets compressed, that spring obviously needs more and more pressure the more it gets compressed. This is why to open the rod for more distance, it kind of needs to have a bit more pressure. This is why these wastegates only fully open, or the boost you are going to run it, even if the wastegate says, or if the wastegate is in theory 0.5 bar cracking pressure, then you're probably gonna run at about 0.6 or 0.7 bar or something like that, because that's where the wastegate is open enough to let out enough exhaust gas or bypass enough exhaust gas from the turbo to get that running. The next thing that can be quite dangerous to engines, although not as bad for the rods, but still can be quite bad if you don't look after it, is boost creep. This is basically if your wastegate, for example, you can see that quite well on an external wastegate. So while the exhaust that goes through your exhaust manifold, in theory, if you wouldn't have a wastegate, went through the turbocharger, everything that you have or that your engine spits out basically does have to go through the turbo, or would have to go through the turbo if you didn't have a wastegate. Now the wastegate comes in to regulate that boost pressure and regulates how much air actually goes through the turbine housing. So you have different openings. A wastegate of this size, for example, this is a 44mm wastegate, like a fake tile wastegate. So this opening is 44mm. On most of the internally wastegated turbochargers, like this one, the wastegate would be a lot smaller. And boost creep happens when the opening for the wastegate is way too small, and then you see the boost, although your wastegate is already open fully, so when your wastegate is already open fully, but the boost still keeps rising, and although you should be able to achieve a boost level of 0.8 or 0.9 bar, it is rising slowly with RPM. That's called boost creep. And you might be ending up at like 1.2 bar or something, although you wanted only 0.9 or even 1 bar. So that is boost creep. How can you prevent this, or how can you optimize a turbocharger to not have boost creep? Well, there are basically two things. If you have an external wastegate, there is the placement. So ideally, you would have the external wastegate in the flow of the exhaust gases that exit your engine and into the turbo. Most of the times this isn't really possible. So it's kind of relying on the pressure inside the exhaust manifold to be enough so that the exhaust gases can exit the wastegate without changing the boost pressure much. In most cases, as I said, this works, but there are scenarios where this is possibly not enough, and then you have to change your setup and reposition your wastegate. The other option is if your wastegate is too small. This can also happen in an external wastegated solution in an externally wastegated engine, although as the smallest units are 38mm, it's not as common. More common is it on a normal internally wastegated turbocharger, where you have, for example, on a GT2860 or something, where the wastegate opening is relatively small, and if you have a free-flowing exhaust, then it is possible that you run into boost creep issues quite early, because, as I said, the engine flows maybe really well, and that turbo is just not able to handle all of the exhaust gases, or the wastegate is just too small. You can port this with a Dremel, for example, to get better results and to avoid boost creep. So you have checked the opening of the wastegate. So when does it start opening? But yeah, you don't want to buy a new actuator. So what can you do about that? Well, there is the possibility to change the preload. As you can see here in this example, the actuator obviously does not reach the hole, or does not reach the pin for the wastegate. So you would have to pull back the wastegate to reach the hole and put it in. And that distance is measured, or that distance measured is the wastegate actuator preload. And this determines also kind of, not necessarily to 100%, the opening pressure of the wastegate. The lower the preload is, the earlier the wastegate is going to open. But the effects of that are not that huge. On a maximum level, this is going to be like 0.05 to 0.1 bar, so like 1 to 2 psi. But it can make a difference if the preload is relatively high. In theory, the optimal preload would be 2 to 3 millimeters. But there has to be some preload, as if there wasn't, you can reduce, or your spool times will be reduced quite drastically, as with the wastegate cracked open slightly, for example, there is going to be a lot of exhaust gas leaking past it and therefore making your turbo spool quite slowly. So you have to consider this when adjusting it. But as I said, this can prevent your turbo from boosting that high or from reaching that high of boost pressure. But you still gotta watch out, and it's not really the perfect solution. The better solution probably is gonna be buy a adjustable actuator, so an actuator that you can actually open up and change the springs within. They can be had for about, depending where you get one, from 60 to 120 bucks. And also depending on how many springs, what sizes, whatever. TurboSmart, for example, makes ones that are quite expensive. And then there are ones from Pulsar, for example, or from Kinugawa or Mamba that are quite cheap, but they still offer a lot of adjustability as they have a lot of springs inside them. On external wastegates is quite a different story because they obviously are adjustable all of the time, or in any case. The issue with that is, or the issue with those is, if your flow of the exhaust or the exhaust manifold is quite good to the wastegate, it is oftentimes not a reliable source to look at the springs for the from manufacturer. For example, if they say this spring is good for 0.8 bar or 12 psi, in most cases, this is going to be a lower number if your exhaust manifold is set up well for the wastegate. So this means that the exhaust back pressure within the manifold is going to work with the wastegate in pushing up the wastegate earlier than it actually should open. So you are going to have to use a tighter spring in your external wastegate most of the time, or on smaller engines, to achieve the desired boost pressure, or just use an electronic boost controller. That would be the second option, although that's something completely different. But you gotta be careful of that, and also be careful that you don't use too much or too stiff of a spring so that you are using or achieving too much boost, obviously. So that's so much for this. As I said, I'm going to also show you the log with that wastegate where I had that actual problem, so that you know what I'm actually talking about. So, okay, as I have shown in the video, you need to watch out what your actuator is doing and how your actuator is actually working, because in this example, I am using, or I have a log from a MX-5 or Miata, however you want to call it, NB with a 1.6 engine, which is completely bone stock. And that car was using a Kraken kit with a GBC 22-350 turbo. I had the same issue with a 17-250 turbo, so that doesn't really make a huge difference, because it's had the same issue as now. So yeah. And when we actually changed the wastegate actuator to a Chinese unit, it worked flawlessly. So yeah, it's definitely the actuator, and why you need to check them, which is very, very important. If you don't know, a 1.6 MX-5 engine is capable of handling around 300 horsepower at the maximum. So this would be with a relatively small turbo. Yes, they can handle more with bigger turbos. They are known to handle upwards of 400, even on the stock rods, although then with very large turbos, and that is not really the goal here. That car is kind of a yeah, back road car, whatever, and is supposed to spool well also. So that's why this turbo was selected, and to get a bit more power out of it than the GBC 17-250. So looking at the logs here, we did run just wastegate pressure, so running the wastegate directly to the compressor housing. So in theory, the shortest way possible to get the wastegate to actuate as quickly as possible, and to get the boost level as low as possible. We also set preload from the original Garrett 3 to 4 or 5 millimeters down to about 2 to 3 millimeters. So that's also something we did. And if we zoom out and look for a pull, which was, I think, here or so. Yeah, that looks quite good. And there is a pull on, I think that's second gear or something. Yeah, that might be second gear. Okay, so we have on this upper one, we have TPS on the yellow line. So we started the pull at 2000 RPM in third gear and went full throttle here. And you can see boost PSI is on the green line. So, well, even at 3000 RPM, we already had like 5 PSI of boost, which is fine. The turbo obviously is capable of doing around, or capable of achieving around 350 to 380 horsepower. So it's quite a bit bigger than it actually needs to be for a stock engine. Now where the issue comes in. While the boost pressure, or while the actuator says it is going to be opening at 0.5 bar, at least it is spec'd that way on the Garrett website, and this car uses a 3-inch exhaust system with a cat, so the back pressure is, although not very high, it is there. And yeah, if we go forwards, we see the boost increasing. 0.5 bar should be around here. 7.8 psi is 0.5 bar or thereabout, rather 7 psi. This is where in theory the wastegate should start to open, and then the boost, obviously, while the wastegate cracks open at 0.5 bar, the boost should end up at like 0.6, maybe 0.7 bar, because obviously while it cracks open at 0.5, or should crack open at 0.5, it has to open quite a bit more than that cracking pressure to actually get all the exhaust flowing through the wastegate opening. So as I said, you should be looking at around a 10 psi or so, yeah, boost level. But the issue is here, even though it is spec'd for 0.5 or 7 psi, well, up to 3700 RPM, we are looking at 14 psi. So what does that tell us? Well, we took off that wastegate and checked when it was actually opening. It was opening at about 0.8 bar or 12 psi. So we saw that the spec of the wastegate or the actuator was actually not where it was opening, which is kind of dangerous, because especially if you run a stock engine, like in this case, while yes, as you can see here in the second one where the spark advance is, I have taken out a lot of ignition advance to lower down the torque a lot to protect the rods from bending. But if you didn't do that and ran full, like you could run 16 to 18 degrees with good fuel of timing, which would create about maybe 30 to 40 Newton meters more torque in that range. And that would lead to probably, if that was done repeatedly, the rods maybe bending, maybe even breaking. And obviously you do not want that. And that is the issue with things like those. You expect the wastegate to open at 0.5 bar and it doesn't, and opens at like 12 to 14 psi. And that's not even the worst thing, because in our case, as I said, we are having a restriction in the exhaust. If you used a catless exhaust, for example, the wastegate pressure would peak a bit higher because of the less restriction, and you would achieve around, I think a guy on Facebook said he was reaching up to 1.2 bar at the limiter. As you can see here, we also have some slight boost creep from the 14 psi I just mentioned. Further up in the rev range, we are hitting 15 psi at about 4500 RPM, and then almost 16 psi at 5000 RPM. While on the higher RPM, it is not that bad if you are running more boost, because the higher the RPM, the less time the pressure in the combustion chamber is acting onto the rods. So that's the same as with the transmission, for example. It is not as bad, but it's still, if it has a lot more, or the boost is rising a lot more than that, for example to 1.2 bar or something, that could be a problem also. So you gotta watch out for that. And of course you have to look out for fueling as well, which I obviously did. We are running at AFR 11.4 or between 11.8 and 11.4, so that's not too bad and is pretty good for a turbo application. But if you did not expect the boost to go that high, then you might lean out the car, which is also very, very bad, especially if you run stock pistons that don't like a lot of knock or detonation. Yeah, and that's basically the biggest issue we have here. And this is why you always want to check your actuator, your opening boost pressure, because as I said, even when you are buying a genuine Garrett article, it might not be correct or as advertised. Again, I have had the same issues with the smaller version of the GBC turbos, but only have heard of that with the GBC turbos and not with the other ones. So I'm not sure if there are others affected, although I would still recommend you check your actuator or even your external wastegate always before doing any pulls. And yeah, so much for that. The other issue that would be of course boost creep in a heavier form than I have experienced here. As I said, we have some boost creep here, but on the GT25 series of turbos, for example, when you have an engine or a manifold setup that flows really good or really well, then you might have more pronounced boost creep issues than I have here, and you might have issues controlling the boost at all. And then you might be needing to port the wastegate port, so make that larger so that the wastegate port is able to bypass enough exhaust gas from the turbine to control the boost properly. And yeah, that's basically it for this video. That was just a PSA basically of how to avoid blowing up your stock engine. I hope you could learn something from this, and I hope that you check your wastegate actuators before trying to tune the car. And yeah, otherwise I wish you a nice day and goodbye.